On time value of money, we are going to talk about the future value and the present value. So I want us to start with the future value. I want us to start with the future value. The future value, as I have said, it is the process of finding an equivalent amount in the future compared to what you have right now. So if you have 5,000 right now, you might want to know what is the equivalent amount in maybe 3 years' time, in maybe 2 years' time, and such kind of a thing. So the process of getting the future value is known as the compounding. The process of getting the future value is known as compounding. Compounding, therefore, it is the process of getting the future value of a present amount. The process of getting the future value of the present amount is what we call compounding. And in this case, we shall be interested in getting what we call the interest. We shall be interested with getting what we call the interest. The interest in this case, we have got two types of interest. We have got the interest we call simple interest, and we have got the interest we call compound interest. So interest, it is the extra amount you are going to earn or pay on a certain amount of money we call principal. So if, for example, you have borrowed money from the bank, you cannot be able to pay your loan using the exact amount that you borrowed. You are going to pay with something on top. So what you are going to add on top of what you have borrowed is the interest. Is the interest. So if you have borrowed 5,000, but you return to the bank maybe as 6,500, so 6,500 minus 5,000 that you borrowed, the difference, which is 1,500, is the interest. Alternatively, you can invest your money. Maybe you have taken your 10,000, you have deposited in a savings account, you wait for 5 years, and then after 5 years, you go and withdraw the money that you deposited, plus the interest the money has earned. So whatever that is going to be on top of the 10,000 that you invested is going to be the interest. So interest can be computed on simple basis or on compound basis. So I want us to start with a simple interest. The simple interest, it is the type of interest in which the money that you borrowed or invested is the only one that earns the interest. Whatever you borrowed or whatever you invested only is what earns the interest. That is to say, if I have invested 10,000 shillings, I've invested it in 3 years, and then the interest rate, the rate of interest is maybe 10% per annum. And then I'm told that this money is going to earn interest on simple basis. It is going to earn a simple interest. In that case, the simple interest for year one, the interest will be given by, remember, whatever you invested is your principal. This one is your time, and this is the rate of interest. So the interest here would be the principal times the rate times time. This rate is always in percentage. The rate is always in percentage. So the interest for year one is going to be 10,000 times the rate, which is 10%, times time. Remember, we are talking about 1 year, year one only. So it is 1 year. You find that the interest is going to be what? The interest is going to be shillings 1,000. For year two, the interest will be equal to what? The principal, which is still 10,000, times the rate, which is 10%, times another 1 year, because it is from the beginning of year two to the end of year two, which is only 1 year. You find that the interest is going to be 1,000 again. When we go to year three, the interest will be equal to principal, which is 10,000, times the rate, which is 10%, times another 1 year, giving you 1,000. So when we are talking about simple interest, the interest is computed on the principal amount. The principal amount. And because the principal amount does not change, the principal amount does not change, this interest will also be constant. It won't be changing. Eh? The interest is constant because it is calculated on the principal amount, and because the principal amount is constant, also the interest will be constant for all those years. That is where we normally come here and say that the entire interest, remember this is 1,000, 1,000, 1,000. So for 3 years, that money will have earned interest equivalent to 3,000, equivalent to 3,000. So whenever you are given the principal, the period, and the rate of interest, the interest in this case, the interest in that particular case can be computed simply using the formula interest is equals to principal times the rate times time. Right? And this rate, remember, it is always in percentage. Like in our example here, the principal is 10,000 times the rate, which is 10%, times the period, which is 3 years. Huh? So you'll find that this one is going to be 1,000 times 3, which is the same as 3,000. Huh? So you get the 3,000 that we got in that side as 1,000, 1,000, 1,000. You can get it once as 3,000. So I want you to pick this up, that simple interest. It is the type of interest that is normally calculated on the principal amount. It is calculated on the principal amount. And in that case, that particular interest is always constant. All over the years, it is going to be earning. It is going to be earned or to be paid. So that is the simple interest. The simple interest. Interest that is normally earned on the principal amount only. Sometimes you can be given a question that is asking you anything. Anything. So if in this case, where the interest is 3,000, if you are asked, how much money did the person get from that particular investment? So the total amount is going to be given by the principal amount plus the interest. So amount is normally denoted by A is equals to principal P plus interest. In this case, our example, the amount of money the person is going to withdraw from the savings account, it is the 10,000 that he made as a saving plus the 3,000 that has been earned as an interest. So the person will go there and withdraw 13,000. That is the total amount. So amount is normally given by the principal plus the interest. That is what you are going to get if it is a saving. But if it is a loan, the 13,000 is what you are going to pay for you to clear that particular loan, for you to clear the loan. So amount is principal plus interest. Amount is principal plus interest. Sometimes this can actually change. You can be able to move along with these formulas and get anything. So it is not a must that every time you'll be asked to compute the interest. Sometimes you can be told to calculate the principal. Sometimes you can be told to calculate the amount. Sometimes you can be told to calculate the rate or even the time. So you can be able to move around with those particular formulas. Then, after introducing that, we can also discuss something small about the compound interest. The compound interest. The compound interest, it is interest that is normally earned. It is the interest that is normally earned, not on the principal amount only. It is interest that is normally earned on the principal amount plus the interest on the previous years. So the interest that was earned in year 1, it is also going to be used in calculating the interest for year 2. Or in short, that interest for year 1, it is going to be added to the principal amount so that now we can use the cumulative amount in getting the interest for year 2. Like in this example we had here, the principal was shillings 10,000. The rate of interest was 10%. The period, which is normally denoted by N, was 3 years. If the interest was being compounded, this is what will happen for year 1. The interest will be given by what? The principal, which is 10,000, times the rate, which is 10%, times time, which is 1 year. You find that the interest is 1,000. So, meaning that by the time we get to the end of year 1, your money, which is 10,000, has already earned 1,000. So when you start the new year, which is year 2, your money in the bank will be the 10,000 that you deposited, plus the 1,000 that has been earned as interest. So already your amount in the bank has grown to 11,000. So when you go to year 2, you will not use 1,000 as your principal. You are going to use 1,000 plus 1,000. It is going to be 11,000. Your principal will be 11,000 times the rate, which is 10%, times the time, which is another 1 year. You find that this time it is coming to shillings 1,100. That is your interest for year 2. For year 3, the principal is not 11,000 anymore, because this was the amount by the beginning of year 2. But by the time we go to the end of year 2, the account has also earned an interest of 1,100. So as we are speaking, the beginning of year 3, the amount that has been earned in our account is 11,000 plus 1,100. So it is 12,100. That is going to be your principal, 11,100 times the rate, which is 10%, times another 1 year. This one will be equivalent to what? 1,210. That is the amount of interest that will be earned in year 3. So in compound interest, the interest that is earned in that year, it is added to the principal so that now you can be able to get the principal for the next year. So the principal for the next year plus the interest for that year, you add together, you get the principal for the following year. So if we were to go to year 4, we will use a principal of what? 12,100 plus 1,210 that was earned in that year. That is going to be our principal. Then the rate is constant times time, like that. So the interest for year 1, it is part of the principal for calculating the interest for year 2. For year 2, the interest of year 1 and year 2 are added to get the principal for calculating the interest for year 3. When you go to year 4, you add the interest plus this interest plus this interest. You add to that principal, you get a figure that you are going to use to calculate the interest for the next year, like that. So it goes on cumulatively, and that is what we call compounding. With the simple, the interest is always on principal, and the principal is constant. But with compound, the principal amount goes on increasing because the interest for the previous year, they are added in getting the amount of principal that will be used in calculating the interest for the subsequent year, like that, like that, like that. So one thing you can agree with me is that when you have got so many years, maybe you are told you calculate the amount after 20 years, getting this particular procedure all the way up to the 20th year, it can be quite tiresome. So on that note, we have got what we call the compound interest formula. We have got the compound interest formula. Compound interest formula. And the compound interest formula states that amount is normally given by the principal into bracket 1 plus rate. Rate, remember, is always in percentage power n. It is normally given by that particular formula. The amount after n years, it can be 3 years, 5 years, any number of years, it is given by the principal, which is the amount at the initial point, whether deposited or taken as a loan. Then you multiply by this, where P is the principal amount. Where P is the principal amount, R is compound. R is compound interest rate. R is the compound interest rate, and N is the duration. N is the duration, which is normally in years. N is the duration in years. So you substitute that, you get the amount after those years. And that is how we do the compound interest. So like in our case here, if we want to get the amount after this, somebody can add for me. If you add 12,100 plus this, so that you can get the amount at the end of year 3. 12,100 is the amount at the beginning, plus the interest, which is 1210. This one will give us what? 13.
310.
13, 310.
310.
That is going to be the amount after 3 years. And that 13, 310 is simply obtained by the 10,000 that we started with, plus 1,000 plus 1,100 plus 1210. So it is the amount, the principal amount plus the interest. You get that. So this figure can also be obtained by using the formula. And we shall say that amount will be equal to what? This is amount, is given by the principal amount, which is the 10,000 into 1 plus the rate of interest is 10% power. How many years? We were going up to year 3, so it is up to power 3. So you find that this is going to be 10,000 into 1 plus 10 over 100 is the same as 0.1 power 3. You will find this one to be 10,000 into 1.1 power 3. So you realize that this is going to be 10,000 times 1.1 power 3. Those with the calculator, they can do that computation. 1.1 power 3. Anybody with a calculator? 1.1 power 3.
Hello.
Yes.
The 1.331.
1.331. So 1.331 you multiply by 10,000. This 1.331 you find that it's going to be 13,310. If you find that, you are going to get the same figure. 13,310 is the amount. So that is the application of the compound interest formula. The compound interest formula can be applied in getting the amount after n years. In getting the amount after n years. So the key thing I want you to understand is that the compound interest, it is when you do what we call compounding. The interest for the previous year, you add it to the principal amount for you to get the principal amount to be used in calculating the interest for the next year, and it goes on like that, like that. So because the formula, the process can be long and actually cumbersome, we summarize it using the formula to make our work easier. To make our work easier. Any question up to that point? Okay, it seems it is okay. It seems okay. The next thing we are going to do after the compounding is what we call the multi-period compounding. We have got what we call multi-period compounding. So sometimes compounding can be done more than once. Instead of calculating the interest once per year, as we are doing here, whereby we had year 1, year 2, year 3, so we are doing it only once per year. Sometimes the interest can be done or can be calculated more than once in a year. You can be able to calculate the interest either twice in a year. If you do twice in a year, it is known as semi-annually. If you calculate the interest twice per year, you are doing the interest semi-annually. So if it is once, as we did, is known as annually. You are calculating the interest annually. If it is twice, semi-annually, sometimes you can do it 4 times. It can be 4 times. If it is 4 times, we normally call it quarterly. If it is 4 times, we normally call it quarterly. Sometimes it can be 12 times. This one is said to be calculated monthly. It's said to be calculated monthly. So if you wait for the whole year and then you calculate the interest after the 12 months, which is 1 year, then you are calculating your interest annually. If you are doing it twice in a year, that is at the middle of the year and at the end of the year, then you are calculating your interest semi-annually. If you are doing it 4 times, it simply means that you are calculating the interest after every 3 months. A quarter is just 3 months. A quarter of a year is 3 months. After every 3 months, you calculate the interest. After another 3 months, you calculate the interest. 3 months like that. So you will be doing it 4 times, and that is quarterly. And then you can decide to do your compounding every month. Every month, you calculate the interest. And because we have got 12 months in a year, then you will be doing it 12 times. You will be doing it 12 times, or you are compounding monthly, So when it is multi-period compounding, or sometimes known as the intra-year compounding, the formula changes slightly. We know that when it is annually, amount is given by P into 1 plus R percent power N, like that. When it is annually. When it is annually, that is how we calculate the amount. But now, that is for the case of number 1, annually. You are doing it once. What about if you are doing the compounding twice in a year? Or if you are doing the compounding semi-annually, what will happen? One thing you will realize that the number of times you are going to do the compounding will go up. Like for example, if it was 3 years, if it is annually, then we are going to do the compounding 3 times only. We do compounding in year 1, we compound year 2, and we compound year 3. So those are only 3 times, and then that amount is determined. What about if you do semi-annually, that is twice in a year? You realize that year 1 only, we have done twice. Year 2, we do another 2 times. So up to the end of year 2, we have done 4 times. 2 in year 1, 2 in year 2. And then we do again 2 times in year 3. So in total, we would have done 6 times. We would have done compounding 6 times. That is 2 in year 1, 2 in year 2, 2 in year 3, a total of 6 times. So our N will not be 3. Our N will not be 3, because 3, it is actually the number of times you are doing compounding for that particular duration. So our n will be 6 times. What about the rate of interest? Remember, in the question, you'll be given the rate in what? Per annum. The rate is normally given per annum, meaning per year. If the rate is given as per annum or per year, but you are doing compounding semi-annually, then this rate needs to be adjusted. If it was, like, for example, 12% per annum, this 12% is when you wait for the whole year. But if you have decided to do it semi-annually, then you need to divide it by 2. If it is semi-annually, you divide by 2. So that you can be able to know that 6% is for the first half, the other 6% is for the other half. So when you combine the two, they give you 12%. So from that explanation, the formula will change like this. If it is semi-annually, it will change like this. Amount will be equal to principal into 1 plus R over 2. We divide the rate by 2, and remember it is percent, and then N we multiply by 2 when it is semi-annually. The rate is divided by 2, the N is multiplied by 2. And you can agree with me, in this case, if it is annually and it was 3 years, it is going to be done 3 times 2, which gives you 6. And the rate of interest, if it was 10%, we shall do 10 divided by 2, we shall use 5% because it is semi-annually. What about if it is quarterly? If it is quarterly, remember we have said quarterly, it simply means that it is going to be done 4 times. It is going to be done 4 times. So if the rate was 12% and you are doing it 4 times, you divide that rate by 4. You divide that rate by 4, and you find that the amount will be given by principal into 1 plus R over 4% power N times 4. So if it is quarterly, divide the rate by 4, multiply N by 4. Multiply N by 4 if it is quarterly. What about if it is monthly? What about if it is monthly? The amount will be given by P into 1 plus R over 12, because we are doing it 12 times, and then N power or N times 12. Power N times 12. So you need to understand that if it is annually, that is the formula. If it is semi-annually, the rate must be divided by 2, the N must be multiplied by 2. If it is quarterly, the rate is divided by 4, N is multiplied by 4. And then if it is monthly, divide the rate by 12 because you are doing it 12 times, multiply N by 12 because it is going to increase the duration. If you are doing it 12 times in a year and you are doing it 3 times or 3 years, then you are going to do 12 times in year 1, 12 times in year 2, 12 times in year 3. So that is the same as 3 times 12, which gives you 36 times as the number of compounding that is going to be done. Generally, the formula for multi-period compounding is given by this. If it is multi-period compounding, amount is normally determined by principal into 1 plus R over M, and this one is percent power N times M, power N times M, power N times M, where M is number of times compounding. Number of times compounding is done in a year. Number of times compounding is done in a year. If it is semi-annually, it is twice. If it is quarterly, it is 4 times. Just a minute, it is worth noting that we can have the multi-period compounding, and in that case, compounding is either done semi-annually, quarterly, and monthly. So if it is semi-annually, your M is going to be 2 because you are doing it twice in a year. So you divide by 2, you multiply here by 2. If it is quarterly, you are doing it 4 times, so your M is 4. So it is going to be over 4. That is the rate, and then N times 4. If it is monthly, then your N is 12. You divide the rate by 12, you multiply the period by 12, and that is going to give you the amount after the end of a particular duration. After the end of a particular duration. So that is actually what you need to understand as far as compounding is done. So I'll leave it at that point in compounding. So when we meet on Friday, I will share the questions with you, and then we shall be able to put them into practice to see how do you apply these formulas in solving the questions. So the other thing that I want you to know about compounding, still under compounding, you can have a case whereby you are saving some money. Maybe you want to buy something after 4 years. But because you know after 4 years you cannot be able to raise the entire money, you can decide to do some savings. Meaning that year 1 you put some money in the bank, and that bank maybe it is paying you some interest. In year 2 you put some money in the bank, still earning some interest. Year 3 you put a certain amount of money, and then year 4 you deposit a certain amount of money such that when you withdraw your entire savings, that amount of money will be enough for you to buy whatever you wanted to buy. Let's give an example like this. You want to buy an equipment. You want to buy an equipment costing shillings 250,000 after 4 years, or 4 years from now. You want to buy an equipment costing to 50,000 shillings 4 years from now. Then you decide to have the following. You decide to have the following saving plan with a bank that pays let us say compound interest, that pays compound interest of 10% per annum. So you have the year and the amount saved and the amount that you save. So you have year 1, year 2, year 3, year 4. Don't forget, it is earning interest. So maybe year 1, you deposit 30,000 in that particular account. Year 2, you deposit 45,000 in that account. Year 3, you decided to deposit 80,000 in that account. And now you want to know now, year 4, how much are you going to deposit or to top up for you to be able to have this amount that will make you buy that particular equipment. Not forgetting that the money that was deposited in year 1, it was earning interest. It was earning an interest. Year 2 is earning an interest. Year 3 is earning interest. Year 4 is earning interest. And let us consider an example whereby money is deposited at the beginning. Deposits are at start of year. Deposits are at start of the year. So year one, or as we are talking right now, this is our current year, you deposit a certain amount of money. You deposit a certain amount of money. Right now, year two, as it is going to start, you top up, you deposit another 45,000. Year three, you deposit a certain amount of money at the start, and therefore year four, you need to deposit a certain amount of money also. Therefore, the amount that was deposited in year one, it is going to earn interest for how many years? Remember, you have deposited like right now, and then you are waiting it up to the end of 4 years. So you realize that the duration it is going to take, the duration of these savings, in terms of N, this amount of money, it is going to have been saved for 4 years. That is, we deposit it right now, that is the beginning of the year, then we wait up to the end of year 4. So it is going to be in the investment for year 1, year 2, year 3, and the whole of year 4, so that now we withdraw it at the end of year 4. It is going to have been saved for 4 years. The duration is 4 years. Then after year 1 has gone, after the end of the 12 months of year 1, we deposit another 45. And remember, our target is at the end of year 4. So at the end of year 4, we need to withdraw the entire amount of money. So this amount that we have deposited at the beginning, or at the start of year 2, it is going to earn interest for only 3 years. 3 years only. That is the year 2, year 3, and year 4. Only 3 years. So it has a duration of 3 years. What about this 80,000? It is deposited at the start of year 3. So it is going to earn interest the whole of year 3 and the whole of year 4, 2 years only. And what about this amount of money? It is deposited at the start of year 4. So it is going to earn interest for only 1 year. It is going to earn the interest for only 1 year. But remember, we want to know the amount that we are going to earn for all this, so that now the total amount is going to be equal to what? To 50,000. So we want our future value to be equal to 250,000. So what you are going to do here, you are going to do some calculation. You are going to do some compounding. And you say that the amount that was in year 1, and then you write here amount, and then we write here the future value of that amount. So the amount that was deposited in year 1 was 10,000. That 10,000, it is going to be having an equivalent of how much for 4 years. So it is going to have 10,000 into 1 plus 10%.
Excuse me, Mwalimu.
Yes.
Excuse me. Is it 10,000 or 30,000?
Oh, 30,000. Thank you for noting that. It is 30,000. It is 30,000. So this amount of money, it is going to have been saved in 4 years. So it is going to have a future value of power 4. A future value of power 4. You get that amount there. For the second year, too, the amount is 45,000. It is going to earn interest for how many years? It is going to earn interest for 3 years, the duration. So it is going to be 45,000 into 1 plus 10% power 3 years. You get the amount for that. For year 3, the amount that we deposited is 80,000. So the total amount that we are going to have up to the end of year 4, those are 2 years. It is going to be 80,000 into 1 plus 10%, 10% power 2. And then this amount we don't know. This amount we don't know that will be invested in year 4. We can call it what? X amount. So the amount, we know the duration actually is only 1 year. It is going to be x into 1 plus 10%, 10% power 1. And then this figure plus this figure plus this figure plus this figure, it must add up to 50,000. So somebody who is a bit faster can do it for me. This one is 1.1. 1 plus 10%. Remember, 10% is 0.1. 0.1 plus 1 is 1.1. 1.1 power 4. It is giving me 1.4, 1.4641 times 10,000. You get it is going to be 14,641. 14,641. For the other one is going to be 1.1 power 3. You get 1.331 times 10,000. You get it is 13,310. This is going to be 1.1 power 2. You get it is 1.21 times. I think I'm not doing it right. I think I'm not doing it right. This is 30,000. I think I multiplied by 10,000. Just a minute. 1.1. You get a total of 1.4641 times 30,000. You get is actually 43,923. Yeah? This one is going to be 1.1. 1.1 times 1.1 times 1.1, you get it is 1.331 times 45,000. You get 59,895. This is going to be 1.1 times 1.1 or 1.1 squared. 1.21 times 8,000. You get 96,800. And this one will be 1.1 times x, which is 1.1 x. So after getting those values, you can come here and form up an equation. We know the total amount should be equal to 50,000. So 50,000 is equal to 43,923 plus 59,895 plus 96,800 plus 1.1 x. And then now you can be able to put the value of x, which will be the amount that will be deposited in year 4, so that now the total amount plus the interest will be equal to this, will be equal to 50,000. So the key thing to understand is the duration. This money that has been saved here, it is going to be in investment for how long? You get that. This one is going to be investment for how long? You get that. It is going to be for investment for how long as you apply it using the compound interest formula. So the future value is compounding. And compounding, you just use the compound interest formula for you to be able to get the future value of an amount.
We can't be able to see clearly.
Is it okay now?
Yes.
So get the amounts, then you add them. So it is only x that is not known. You can add this plus this plus this. You come here and you subtract from to 50,000. So you get a certain amount of money, or I can just go ahead and finish that. $800 plus 59, 895. As complete. And that it is going to be 250,000, 200 618 plus 1.1x. I've just added this and this and this to get this, so that now we can say 250,000 minus 200 618 is equals to 1.1x. So get it is going to be 49,382 is equals to 1.1x. So 49,82. You get that 49 divided by 1.1 is going to be x.
44,892.
You get
44,892.7.
okay. Yes, 44,892.7. That is the amount of money that will be deposited in year 4, so that the person can be able to attain the goal of having 250,000 to buy the equipment. 250,000 to buy the equipment. Any question up to that point? If there is no question, that is all about compounding and getting the future value. So what is remaining is for us to be able to understand how we do discounting. How do we get the present value? So this is when you have the amount now and you want to know its value in future. And you want to know your value in the future. So you wonder, how are you going to get it? So that is the future value or the compounding. The opposite is true when you are promised. Somebody is promising you to give you 10,000 after 5 years. You can be interested in getting the equivalent amount now. The 10,000 is going to be received in 5 years. So that is a future value. So you are interested in knowing the equivalent amount right now. So you are interested in getting its present value. So how do you get the present value? So the present value or the PV is normally computed using the process we call discounting. The process of getting the present value is known as discounting. So this is an amount that is going to be received in future. It is an amount that is going to be received in future, but you are interested in knowing this person is telling me that is going to give me 10,000 after 5 years. What if the person gives the money right now? How much is equivalent to that? So you are determining the present value of a future amount. So the process of discounting is the process of getting the present value of a future amount. A future amount because that amount is going to be received in future. But remember, compounding, you have the money now, you want to know its value in future, so you do compounding. Discounting is very vast. So the present value of an amount is normally given by amount that you are going to receive, then you multiply by 1 over 1 plus R percent power n. So in short, you find that amount times 1 is going to be amount over 1 plus R percent power n. That is how we do the discounting, and it will give you the present value. It will give you the present value. So whereas compounding, we are multiplying the figure here with this, the process of getting the present value, you divide. Remember, for future value, we said it is given by P into 1 plus R power n. But in this case, it's right now this over 1 plus R power n. But this is not P, it is an amount, because that is the final amount you are going to get. So you want to get your present value. You divide by that particular factor, which we call the present interest factor. The present value interest factor. That is actually how we do it. So if somebody is promising you to give you 10,000, so the amount that you are going to receive after 4 years is 10,000. The period, which is n, it is 4 years. And then the rate of interest, the discounting rate is maybe 10%. So your present value will be equal to the amount that you are going to receive, 10,000. Then you divide by 1 plus 10% power 4. 1 plus 10% power 4. It is going to give you that particular value right now. So you get it like that. So this is 1 plus 10%. Remember, 10% is 1.1. 1.1 plus 1, 0.1, sorry, plus 1 is 1.1. You raise power 4, you get that. Let me do that computation. You are going to get 1.1 power 4. We start from there. You get, actually, it's going to be equal to 10,000 over 1.4641. So 10,000 divided by 1.4641. Get that 6,830.13 is going to be the present value. That is going to be the present value of that amount. That simply means that if you have got 6,800 and that right now, you can be able to buy something that 10,000 will buy after 4 years. So whatever you can buy, or that particular item which costs 6,800, the item that costs 6,830, that particular item in 4 years to come, it is going to cost 10,000. It is going to cost 10,000, or you require 10,000 shillings to buy the same item. So the discounting, you divide this particular factor by the amount. And compounding, you multiply the factor by the amount for you to be able to do that. So basically, that is what the topic is going to be talking about. So this discounting, we are going to combine with the capital budgeting. So we see how we can be able to evaluate the profitability or the validity of a project using the discounting approach. So we shall meet on Friday, then we work out on examples. We see the questions, how they are tested and how you are supposed to answer them. And then we see how we are going to wind up on that particular topic. So today I wanted you to have the figure or the face of the topic. Then we shall go to the tested questions for us to be able to see how we apply those formulas. So I don't have much for this particular lesson. I want us to end it at that point unless somebody has got a question or a query. Okay, if there is none, then let us do it again on Friday. Enjoy your evening.
You too.
You too.